Hey y'all! Are you ready for another exciting video about project management definitions? Today we're going to talk about Chapter 8 and CPM models. So in Chapter 7 we talked about networks and some different ways that we can use those to help us solve problems, but we can also use networks to help us plan and schedule projects, and this turns out to be a really useful method. Networks show how project activities are related to each other, so it can help us figure out the duration of the project, and it can also help us figure out what things are absolutely critical to stay on target and which things can have a little bit more leeway. We are going to focus on a method called the Critical Path Method, or CPM. The book also discusses PERT, which stands for Project Evaluation and Review Technique. But PERT involves probabilities, and so we're just going to stick with the CPM. A few definitions to get us started. You'll notice this is really quite similar to what we talked about in Chapter 7. We have nodes and branches. The branch, also called an arc, reflects an activity in a project, and it indicates what is called officially precedence relationships, or in other words, which things have to come before something else can happen. The node represents the beginning of one activity, and those activities are referred to as events. When the activity is finished, we say that it has been realized. So this is a house building example that he goes through in the book. We're going to look at this. You'll see that there's some things that have to happen before other activities can happen. So the first thing that has to be done is to design the house. And the second thing is lay the foundation. Well, before they can lay the foundation, they have to design the house. So number 1 is the predecessor for activity 2. And you'll see in that last column the duration, how long it takes for all of these different activities or events. He goes over essentially 2 different methods to draw these projects onto a network. And the first one is called an AON Network, which stands for Activity on Arc. Or in other words, the activity name and the time duration is shown on the branches, and we are allowed to have activities occurring at the same time. You may have noticed on that earlier picture something that was labeled as a dummy activity. A dummy activity is drawn to show a precedence relationship so that we know activity 2 has to happen before activity 3 and 3 has to happen before 4. The reason that we do this is that each activity needs its own node and it needs its own branch. And so that first diagram that you see, where there's 2 things going from 2 to 3, well, that doesn't help us because those are 2 different starting and ending points. And so to solve that, we put in that dummy arc instead. Not to show the passage of time, but just to show that 3 has to come before 4. If that all seems kind of weird to you, then I'm with you on that. I prefer the other way to do it, which is called the Activity on Node, or AON Network. And so this is an example. Every node contains a label at the top. They're just numbered. And then the duration is at the bottom. And then the arrows show us those precedence relationships. And so I like this. To me, this is clearer. It just makes a lot of sense to me. Another definition, and this is an important one. The critical path is the longest path through the network. And so that's how much time it's actually going to take to do whatever it is you're trying to do. So in this case, we're trying to build a house. So if we take all the paths from 1 to 7 and we calculate how long it will take, that longest path is going to take 9 months. So that's how long it's going to take us to build the house. And that path, that longest path, that is called our critical path. It's called the critical path because to keep this project on schedule, to complete it in the shortest amount of time possible, we can't have any delays along that critical path, path A. There can be a little bit of delay in those other paths, and it won't delay the building of the house. Another way to write an AON network is to include not just the activity number or label and the duration, but also to include the earliest possible start time, the earliest possible finish time, and then the latest time that particular activity could start, and the latest finish time, meaning the latest that could finish, and we don't delay the overall project. So here's our house, and we have the activities labeled with numbers and the duration times. So the earliest start time for that first one, the earliest time it can start is month 0. And then that one's going to take 3 months. So those next activities at 2 and 3 can't possibly begin until the 3rd month. So if I fill in these times, it looks like this, and you'll see for activities 2 and 3, we could start in month 3 because by then the design has been finished. So for activity 1, starts at 0, takes 3 months, so the earliest time it can finish is 3 months. So to get from earliest start to earliest finish, we just add the time it takes. Easy enough. To find the earliest start time for activity 2, well, activity 1 has to be finished first, so it can't start until time 3, and it takes 2 months, so the earliest time it can finish is at 5 months. Activity 3 can start in month 3, it only takes 1 month, so it will end at month 4. For activity 4, it needs both 2 and 3 to be finished, and so we're going to take the maximum of the earliest finish time from all immediate predecessors. And the maximum time there is 5 months. So we can't start activity 4 until month 5. And it's going to take 3 months. So then I know the earliest finish time is 8. For activity 5, again, it can't begin until month 5. It needs both 2 and 3 to be finished. So it starts at month 5 and it will end at month 6. That's the earliest finish time. And we keep going to get from 5 to 6. 6 only depends on 5, so it can start in month 6. It takes 1 month, so it ends in month 7. And for activity 7, we're going to, again, take the maximum from activity 4 and activity 6, and so that's 8. We have to wait until month 8 to start activity 7. It takes 1 month, and so our earliest finish time is 9 months. Once we have all of our earliest start and earliest finish numbers, we can go back through and see, okay, when's the latest we could do this? Task 7 there at the end has to end at month 9, which means it has to begin at month 8. So for that last project, we're just going to copy those numbers down, and then we're going to work backwards. Task number 7 has to begin at month 8. We need all the predecessors to be finished at month 8. So we fill in the latest finish time for activity 4 and activity 6. We fill that in as 8. Those have to be completed by then, or our project gets delayed. So if we finish at month 8, when do we need to start? Well, for activity 4, it takes 3 months, so we have to start at time 5, at month 5. For activity 6, it takes 1 month, so we could start at month 7. So notice for activity 6, our earliest start time and our latest start times don't match. And that's okay. It just means that we have some extra time to complete task 6. To go on to task 5. Task 6, the latest time it can start is month 7. So that's going to be our latest finish time for activity 5. And then going back 1 month, our latest start time is going to be a 6. And we continue on that way, working backwards through the network. The difference between the latest start time and the early start time is called the slack. That will also equal the difference between the latest finish time and the early finish time if you've done all your addition correctly. That's the time where we can delay that activity a little bit, and it won't delay the entire project. You will notice that on the critical path, the slack time is 0. Nothing on that path can be delayed without delaying the entire project. And so once we have all the numbers written on the node, we would also want to go back through and write down all the slack times so that we know if there's some kind of a delay on that particular activity, how that might affect the project. In summary, the critical path method is a really useful tool that can help us organize and schedule projects, determine how long it will take to complete a project, and looking for that critical path and the slack helps us analyze where potential problems could be in this project. So that can help us with various kinds of sensitivity or what-if analysis.